Hi everyone, this is Inbal. I'm going to give a brief update on our activities under NASA Harvest. As a reminder, NASA Harvest is NASA's Food Security and Agriculture program established in 2017 and is NASA's contribution to GeoGLAM. Harvest is made up of a diverse consortium of over 50 partners from across the agricultural community, and we developed this consortium largely building on partnerships established under GeoGLAM. We have 30 funded projects that span global down to field scales that are primarily focused on three impact areas: agricultural land use, agricultural sustainability, and agricultural productivity. In addition, we have a series of initiatives, including one on our Africa activities called Harvest Africa, one on rapid response, and one on sustainable and regenerative agriculture, as well as one on domestic agriculture in the US. One of our contributions to GeoGLAM is the coordination of the crop monitor under the GeoGLAM Secretariat. And as some of you are aware, we're now providing on a monthly basis a global map that integrates the assessment from the AMIS and early warning crop monitors to provide a global view of crop conditions. And these maps are being published on the GeoGLAM crop monitor website on a monthly basis once the monitors are published. Some additional updates on the crop monitors. AMIS is now joining the Crop Monitor Telecon. They started doing this back in the summer and are doing this now on a monthly basis. This has been very beneficial for us to both provide the AMIS perspective on the telecons as well as to strengthen the partnerships at the national level. We're also providing global climate forecast sections, both in the Crop Monitor for early warning and AMIS. Regional forecasts are being included within the Crop Monitor for early warning, and these are provided by the UCSB group. We do also have alert sections on developing disasters, for example, on the desert locust situation and on seasonal forecasts, including more recently on the dry conditions in Eastern Africa and in Central Asia. We have a new series of reports on food security and conflict, and we're continuing to publish the special report series on emerging threats to food security. As some of you are aware, ESA, NASA, and JAXA this past summer launched a trilateral COVID-19 dashboard, and the crop monitor assessments are now integrated into this dashboard in order to provide a global indicator on crop conditions. And these are updated again every month once the crop monitor assessments are published. In terms of the national crop monitors, we're continuing to provide support to countries in terms of developing and running their own crop monitor systems, with the most recent country being Mali. And the Mali work is being carried out under a project that we launched last year with USAID and building on our work with the Lutheran World Relief. And the objective is to help develop capacity for early warning within Mali's Commission for Early Warning, as well as to help USAID enhance the design of their household surveys, as these are obviously becoming increasingly challenging to conduct on the ground given the ongoing conflict. We're continuing to have a strong focus on advancing yield forecasting methods and applications, and are increasing our efforts specifically on yield forecasting at the field scale, doing a lot of work in particularly in Argentina, as well as over the US and in Ukraine. We also have a strong focus on advancing methods for in-season cropland and crop type methods using minimal training data. And here I'm showing some examples from our work in the Corn Belt in the US, as well as in southern Russia, that we conducted in support of early area assessments for the 2020 season, given some of the uncertainties that were there. Another example, utilizing our in-season mapping work within the context of our rapid response initiative, was in response to a request by the government of Togo. At the start of the pandemic, the government instituted significant national restrictions, as many countries did, and these impacted the smallholder farmers. And so to support these farmers, the Togolese government launched a program called YOLEM, and this is a digital interest-free loan program that was aimed to improve yields and livelihoods of Togolese farmers by funding farmer essentials via digital wallets. And the problem is that they were using census occupation data to identify farmers that they were going to include in this program, but the census data underrepresent smallholder farmers, as many of them register under other occupations rather than farming, as farming is often not the primary occupation. And so the government requested that we develop a high resolution crop map, and they gave us 10 days to do that, so that they could use that as a proxy to locate smallholder farmers across the country. And so we developed a 10-meter resolution map using GeoWiki, SkySat, and PlanetScope data for training and validation, and we used Sentinel data for the national map. And building on these methods, we recently supported the FuseNet virtual crop tour, developing in-season cropland assessments over parts of Sudan and Ethiopia, again, using the PlanetScope and SkySat imagery for training and validation, and Sentinel data for mapping. We're continuing to adapt these methods for other countries and have just completed a 2020 national cropland map for Kenya. And this is in support of a new project we launched with the Swiss Re Foundation called EO Farm, in partnership with the Kenyan Ministry of Agriculture and CIMMYT, in support of a range of activities, including the farmer insurance program of the Kenyan government. Another example I'd like to share under our rapid response program is in the US, where we were asked to assess the damage to croplands from the derecho that swept across Iowa, which is one of the main agricultural states in the US. The derecho occurred on August 11th. And here we used Sentinel-1 data to map the damage extent as well as the severity, and used the in-season crop type maps to assess the area impacted under soy and corn. In terms of data portals and platforms, we have a new release of our legacy GLAM system that's being used and evaluated extensively by our partners in Brazil and Argentina. And we're preparing to launch the NASA Harvest data portal, as well as a new portal on COVID-19. Finally, building mutually beneficial public-private partnerships continues to be a large priority for NASA Harvest, and we're exploring a variety of different models for cooperation with various actors within the private sector. One of these modalities is through a new initiative that Alyssa is leading called SARA that we'll be launching soon, and that's focused on sustainable and regenerative agriculture, so stay tuned. Finally, I'd like to end my presentation mentioning two prestigious honors awarded to Chris and to Catherine. Chris was awarded the NASA's Distinguished Public Service Medal, and Catherine was awarded the Africa Food Prize. And on a personal note, I'd like to introduce you to the most recent addition to our team, Rafael, who I gave birth to in early September. So with that, I'll wrap up, and I look forward to talking with everyone at the GeoGLAM XCOM meeting. Thanks.